Hi to everyone. In this video, we are going to discuss about another automata called a Turing machine. A Turing machine is an automata whose temporary storage is a tape. So far, we have discussed about the push-down automata. In push-down automata, we are using the temporary storage as a stack. But here in Turing machines, we are going to make use of the tape as the temporary storage. When we are talking about this Turing machines, a Turing machine M is defined by 7 tuples. That is just like push-down automata. Here also we are going to define the Turing machine by means of the 7 tuples, which is defined by M is equal to Q comma sigma comma tau comma del comma Q0 comma blank comma F. So where Q is a set of internal states and sigma is the input alphabet and tau is a finite set of symbols called the tape alphabet. In push-down automata, we have used the tau symbol, but there we are using the tau so as to represent the symbols of the stack. But here we are using the tau to represent the symbols of the tape alphabet. The next one, del. Del is the transition function, and this is a blank, which is also the subset of the tape alphabet. And this symbol is called as a blank. And Q0 is the initial state. Q0 is also the subset of the internal states. And F is the final state. F is the subset of the internal states. It can be, it's not necessary to have only one final state. Even our machine can have more than one final states also. So this is about the Turing machines. When we are looking about the working principles of the Turing machines, you will have the control unit and you will have the tape as a temporary storage. The tape symbols will get stored here. This control unit is responsible for controlling the operations of this machine, and this is a read-write head. When you are taking the push-down automata, we have discussed about we are going to push the symbols onto the stack and we are popping it out. In the same way, here in Turing machines, we are going to read the symbols from the tape as well as we are going to write the symbols onto the tape. By means of this control unit, we are going to control this read and write head. So once after reading the informations or else after writing the informations, your tape head may move either towards left or else towards right. So this is based upon the control unit. We are going to move this tape read-write head either on the left or else to the right of the tape. So that those things that we can define it in the transition itself. Let's see the transitions so that we can easily understand the working principles of this machine. Yes, the transition function del is defined as del such that q cross tau tends to q cross tau across L comma R. It means, what it means is the arguments of the transition. The arguments of the transition are the current state of the machine, current state of the control unit and the current tape symbol being read. And the result is the new state of the control unit and new tape symbol and the movement of the read-write head, whether the move symbol is left or right. So transition, it takes the argument as the current state of the control unit and the this is the input internal state and this is the tape symbol. So by using these things, which will be tends to the new internal state and the new tape symbol, and it depends upon the move symbol, whether the tape is moved towards left or right. So what we are going to do it here is, I am just taking one example for this one. Here the tape containing the symbols A, B, C. So you just see here, your read write head is now pointing to the symbol A. By that time, the machine, the control unit is in the state Q0. So after, now your machine is in the state Q0. By that time it is pointing to the tape symbol A. So after transition, what's happening here is, your read write head is moved towards right. By the time this A is replaced by the symbol D here. So in push down automata, whenever the transition is happening, by that time you are going to replace the, either you will push the symbols or else you will pop it out. In the same way here, what we are going to do it here is, either we are going to replace the tape symbols or else even without replacing, simply either you will move the read write head towards the right or else towards the left. So what's happening here is, in this diagram, initially your machine is in the state Q0. By that time it is pointing to the tape symbol A. While performing the transition function, while applying the transition function, the tape symbol A is replaced by the symbol D, and your tape head is moved towards right, and at the same time your machine is shifted from the internal state Q0 to Q1. So we can define the transition as del of, what's the internal state here, Q0. So del of Q0 comma tape symbol A. So del of Q0 comma A equal to, what's the resultant internal state? It's Q1. So Q1 comma, and the tape symbol here is D. And here we have to mention the movement, whether it's a left movement or else right symbol. Here your tape head is moved towards right, so we have to write it here as R. So here from this diagram we are writing the transition as a del of Q0 comma A equal to Q1 comma D comma R. It means your machine, when the machine is in the state Q0, and if the tape symbol is A, means by that time your machine which will be shifted to the internal state Q1, and the tape symbol A will be replaced by the symbol D, and your tape head which will be moved towards right. And next, just for an example I am saying, now your machine, we can change this one. We can change this one as, here I may give the tape symbol as E. So this is Q1. In case if I am having the transition like this one, means I have to write the transition as a del of initial state is Q0. So Q0 comma the tape symbol is A equal to, here the resultant state is Q1. So Q1 comma A is actually here A is replaced by the symbol D, so we have to write D here, and the tape head is moved towards left, so we have to write the move symbol as left here. So this is about the transition function for the Turing machines. Actually, while doing these operations, this process will be repeated again and again Whenever if your machine is in the state Q0 and the tape symbol is A, your machine will be shifted to Q1. By that time the tape symbol A will be replaced by D and the tape head which will be moved towards the left. So next one thing is about the halt state. The Turing machines can perform several actions like this one. Either your tape head may be moved towards right or left. But when this machine reaches the halt state means if there is no transition, means by that time your machine is said to be the halt state. A Turing machine is said to halt whenever it reaches a configuration for which the transition is not defined. If the transition is not at all defined means by that time your Turing machines which will reach the halt state. This is about the definitions of the Turing machines. In case if you are having any doubts, kindly post by queries. Thank you.